Let me tell you a little bit about VXGI, or Voxel Global Illumination. It's a technology that allows us to simulate light inside of your game in real time. That means that shadows look better, colors bounce around, and the scene is much more realistic. You're looking at a ray-traced image of the Cornell box, which is a classic set of geometry from the early days back in 1984, when everybody was trying to figure out how to do real-time rendering. The problem with this box is that it's actually very difficult to calculate how light bounces it around it in real time. So in graphics, we use simplification techniques. The easiest way to calculate light is what's called direct. That means we imagine there's a point light source that illuminates directly down onto the geometry, but only lights the surfaces that it hits directly. That's why we call it direct light. In this case, you can see the top of the balls are very bright white, the right wall is green and the left wall is red. And that direct light it looks good, but it's missing because clearly you understand that there's going to be reflections. Well, reflections and calculating reflections in real time has been a really difficult problem for graphics. And really until now, it's been practically impossible. This image is showing a voxel view of that geometry. Now, voxels are volume pixels, and it's a way to represent geometry sort of coarser so that we can model real-time light reflectivity. In this view, you're looking at what we call an opacity model. And the opacity model is used to calculate how light is blocked by objects. And you can see that it's made up of these tiny little boxes. That simplification versus the real geometry helps us run this in real time. Now, the next view you're looking at is called an emissive view. In this view, we're taking direct light and we're lighting the voxels. And then we're going to, in the next stage, use that lit voxel to calculate the first bounce of light. In this case, you can see the right-hand wall is very green and the left-hand wall is very red. In the next stage, those surfaces are going to emit light onto the rest of the surroundings. That's effectively how we calculate reflection. Now, as I move the light around, you can see that the voxel geometry is actually changing in response to the way direct light is illuminating the scene. This is just another way to say, okay, we're going to calculate a bounce. So if you look, as that light pans from the green wall to the red wall, the white voxels appear and disappear. In this next scene, the voxels are now emitting light or reflecting the original direct light. You can see the ball on the left-hand side has this sort of reddish glow to it. That's there because remember the left wall is emitting red light. And on the right-hand side, you can see there's kind of a green pale to the right-hand ball. And that again is coming from the right-hand wall, which is emitting green light. What's interesting though is you can also see both walls are now kind of the opposite color that they were originally because of course, each wall is gently lighting the other side. This gives you a real sense of how reflected light would work in the real world. And now we're able to do that in real time. And now let's take all those different forms of light and combine them together to get a final image. In this scene, you're looking at the direct light coming from the top, and it's hitting the walls, and we're adding in that light that we calculated using VXGI. That light gives us the specular highlights. It gives us very beautiful ambient occlusion. The balls look like they're on the ground. What's really extra cool is that you can see the reflection of one ball in the other ball. If you look closely at the ball in the back, you can see this interesting silver shape, which is actually the ball in the front. VXGI is a revolutionary new dynamic lighting technology being delivered with Maxwell GPUs. It's going to change the way games look forever, and we're all going to be the better for it.